Reactions of these triglycerides. I want to take a look at 3 common reactions these go through. Okay, so let's start with hydrogenation. This is probably the most common, most familiar of the 3. The hydrogenation of these triglycerides or triacylglycerols. Okay, so what is happening here is we have our unsaturated fatty acids. Okay, we have them here. Now we take those and we hydrogenate them, which means add hydrogen. Okay, so we add hydrogen across the double bond. Now when we do that, we produce carbon-carbon single bonds. Okay. Now how we do this? Hydrogen gas. We just bubble it through the heated oil, the heated fat, and we like to use a metal catalyst. In this sample, we use nickel. Now these you are very familiar with. Going to the grocery store, going down the baking, cooking aisles. You'll see things like vegetable oils, olive oils, things like that. And then right next to them, you'll see shortening, or you might see various margarines. Okay, or my mother always called them sticks of butter, but they were actually sticks of margarine. Okay, so what happens, what can lead in these hydrogenation reactions, the hydrogen is added across the double bonds, but we control how much hydrogen is added. So we look at stoichiometry, and they let the vegetable oils get partially saturated. They don't let them go completely saturated. What that does is it makes it a thicker, more solid, almost what you would call a semi-solid product that you can mold into the sticks of margarine or shortening like Crisco, or in the bowls or tubs of margarine that you see in the grocery store. And you can use various vegetable oils. You could use like coconut, you could use olive oil, avocado oil. You can use different ones to run through this scenario. Canola, corn oil, those kind of things. But you're hydrogenating the oil, which simply means you are just adding hydrogen across the double bonds in that chain. Okay, and they do it partially, not all of the double bonds, so that they get that semi-solid consistency. Okay, now a positive thing of this with hydrogenating oils is the product doesn't have any cholesterol, which we know has got health effects with heart disease and stroke, things of that nature. But by hydrogenating the oil and turning it into that semi-solid, we're increasing melting point. We're making it more solid, so we're making it more like a saturated fat, which does have severe health effects related to strokes and heart attacks and so forth. So through these products, there's not any cholesterol, but there is this production of these solid or semi-solid fats, which mimic the saturated fats, giving us those negative health effects. So positive on one side, negative on the other, I suppose, when you compare the cholesterol to the saturated fats. And the next reaction type we want to look at is the hydrolysis of these triglycerides or triacylglycerols. Okay, so remember that hydrolysis means removing water. Okay, removing water. So we're shedding a water here. Now what we're doing here is we're cutting it with water. Okay, so we're going across the ester bond. Okay, we're going across the ester bond. Now, when we go across that bond, okay, when we go across this ester bond, okay, so right here, remember, the esters are right here in the middle. And when we go across that ester bond, what we result is we get our glycerol back and we get our 3 fatty acids. So when we go across that bond is split with water, okay, we get back our original components. We get the glycerol and we get our 3 fatty acids. Okay, so we get them back. So where we took a wax and more or less we have 3 of them put together here to make this triglyceride. If we want to split this and break it back down into its roots, into its forming our foundational parts, we can cut these with water, so to say, okay, and get that split apart. When we do that, the glycerol that is produced, remember that is a polar substance, it's a trihydroxyalcohol, it is very soluble in water, okay, and we see glycerol used in sweetening agents, we see it used in soap making, we see it used in a lot of everyday products, and very soluble, very, very polar, but the 3 fatty acids that are there are non-polar. Okay, they're not soluble in water. And just a reminder that these 3 fatty acids that are found, they don't have to be identical. These 3 can be different, or 2 can be the same and 1 be different, but we would yield those 3 fatty acids. Okay. Alright, the final reaction that we see these triglycerides go through, and again, we often use glycerol in this, is saponification, so soap making. Okay, so saponification, and forgive me for this word wraparound, this should be together NaOH. Saponification is soap making. So we take our fat, okay, we take our fat, so we can take our triglyceride, okay, we can take our triglyceride and we can react it with strong bases. The most common ones we use are sodium hydroxide and potassium hydroxide in the presence of heat. So usually this mixture is continuously being stirred and mixed as it's being cooked, so to say. So if you were in a laboratory setting, you might do this over a Bunsen burner or a hot plate with continuous stirring, because what we are doing is we're taking that strong base, we're mixing it with this triglyceride, okay, and it results in the retrieval of the glycerol. So we're going to break this and we're going to get our glycerol back, going to get that, trihydroxyalcohol, we're going to get it back, and we're going to get salts of the fatty acids. So we're going to get the carboxylate salt is what we would be getting there. Okay, in that process of getting that salt of the fatty acid, we typically get either a sodium salt, which these often are solid, more what you would call a bar soap, and the salts of the potassium are softer, more liquid hand soaps, I guess you could say, is what we would see. Okay, so here's a schematic of that reaction, the saponification soap making. So here is our triglyceride. Okay, our triacylglycerol right here. We have our strong base, and we must use heat to speed this process up. Okay, so we would cook it. Now, when that happens, notice again, write down this ester grouping here. Notice right there. Okay, that center piece, what happens? Okay, the glycerol comes off. Let's see the CH2s right here coming off. Okay, giving us the glycerol alcohol here, and then the salts of those fatty acids. Okay, and again, remember, these three fatty acids don't have to be the same. Okay, they can be different. And that is our soap right there. That is our soap formation. And let me fix something right here. Get rid of that 2. Glycerol doesn't have a 2 right there. Okay.